Welcome back to the Craniomandibular course on PhysioNexus YouTube channel. We're now tackling how does it do what it does, and in this case we're referring to the TMJ. In terms of scoping the topic, this series is going to be dealing with first the joint itself, the structure of it, the disc, the structure of that. How does the disc move within the joint? How does the joint move in general? How do the muscles produce that sort of motion for these different movements that we're going to be talking about? How does the disc deal with forces? How durable is it? How does it stay durable? How does it stay in place? How does this maintain stability in this area? How does it get nutrition, the joint itself and the disc, in order to heal? And then how does it get innervated, or what's dealing with the nerves in general in this area? So you have this odd-shaped horseshoe bone that is the jaw, with these two quick angles that then turn straight up towards the skull. And at the connection point, you have a design that is created for both tremendous power, so that you can chew food, break down food, and designed for very intricate fine motor control so that you can speak. Let's get straight into how this joint is made. You see, at the end of the jaw on each side is an oddly shaped football as it goes up into the skull. And it's not very long or wide from front to back, but it is very wide side to side. Now this side to side width is going to make sure that as you move your chin left and right, and as this angle that's coming up is going to move outwards, it doesn't have a chance for dislocation because it has this extra room that it can move on. So you have this extra surface area that's going to make sure that it doesn't easily dislocate. Now the front to back width or design it's much more narrow because it's designed for rotation. It needs to stay in space and almost pivot on a dime. But look at where this football sits up in the skull. This doesn't look like a very good spot. You have this very deep recess and then this sort of like hill in front of it. And that hill, which the jaw is going to move along, it's convex, which means you have convex on convex, which is like trying to stack two balls on top of each other. That's not a very stable idea. This is where the disc comes into play. You see, the disc is in essence two cups on each side of each other. Some people describe it as a red blood cell, and it's going to add a lot of stability to this area. It's almost like this area is actually two joints in this small space. You have a joint that lives above the disc, where it comes in contact with the skull, and a joint below it where it comes in contact with the jaw that points up into it. So let's talk about how this weird two-joint structure actually moves. Well, the main concept of this motion is you're going to have a rotation and a sliding. And this is something that happens in a lot of joints, so it's not unique here. But what is unique about this joint is that the bottom of the disc is going to be where all the rotating happens at the jaw. The jaw rotates on the disc and tries to stay in place and in nice contact with each other. You can imagine this almost like a swing at a playground, where the top of the swing that would be connected to the pivot is the jaw meeting at the disc. That area is going to be a pivot, so this jaw can now swing back and forth and open on the disc. Now think of the top of the disc as sort of a sliding motion. If you look at the recess and the hill in front of it, it almost looks like a slide. It's just you're sliding on the bottom of the slide. So now our swing set is getting a little crazy. It's like a Ninja Warrior obstacle almost, where you have a swinging motion, and as it swings back, it's then going to start sliding at the pivot point forward as it moves forward. Some say in terms of motion that roughly the first 50% of opening is happening at the swinging, and that the later 50% is happening more at the sliding part. The translation of this, well, you only probably rotate or swing when you're doing small motions, and you slide when your mouth is getting much larger motions or opening. Now everyone close your mouths and put your fingers just in your ears, pushing forwards towards those jaws. Now if you just open a little bit, keeping the tongue on the roof of the mouth, you'll feel some motion in there, and that's that rotation. But if you open your mouth really wide, you're going to feel the jaw move away from your fingers. That's that sliding. Now, there can be variability in how much someone can open their mouth. And part of this could be how steep that slide is. If it's a steeper slide, this is going to increase the available range. Now, to make this slide even more fun, let's make it a slip and slide, because this joint has synovium, or healthy nutritional lubricant, all inside it. One of the things that the disc can do for this joint is make this slide nice and easy, aka reduce any sort of friction that might be occurring here.